Showtime!
Ladies and gentlemen, please make your way to your seats.
Showtime!
Please make your way to your seats. The show is about to begin.
Showtime!
Let the magic begin.
So anyway, welcome back to FutureTech Live. I'm here with my co-host, as always, John Irwin, and we got a lot to talk about today. And I think the first one we're talking about is the quantum internet, the first unhackable shopping transactions carried out on the quantum internet. What's going on here?
Really cool stuff. So a lot of new stuff coming out of China. So researchers in China have recently carried out it's more of a proof of concept demo of a secure online shopping transaction using a quantum network, which represents the first real-world application of quantum communications and cryptography. So what happened was the team at Renmin University, I think, built a small-scale network of 5 quantum computers connected by several kilometers of fiber. This setup mimics how a future quantum internet could operate by mimicking the quantum states of photons to transmit and process information. What they were able to do was run an encrypted exchange simulating an online purchase between a merchant and buyer. So by using quantum keys exchanged through the network, they were able to verify each party's identity and ensure the payment details couldn't be intercepted or stolen in transit, something which is pretty much not possible today with classical internet technologies. Now, again, this is limited in scale, but it does prove the viability of quantum techniques for bank-level, secure online shopping, even with quantum networking capabilities. So as more entangled quantum systems are connected globally over time, a full-fledged quantum internet could fundamentally transform secure online commerce and data transfers. The cool thing about this is it illustrates how quantum mechanics offers new avenues for distributing trust and privacy at a massive scale, which is virtually impossible with classical means right now. So it gives us a glimpse into real-world applications that are emerging as quantum technologies advance towards mainstream use. It's really cool. Now, again, you come out with new technology that's unhackable. Eventually, someone's going to figure out a way to hack it. But who knows when it comes to quantum? So there's a lot of interesting information here.
Yeah, unhackable is always something I question because, it's unhackable. Why? Because it's on a private fiber network, or because it's unencrypted, or because of the 1,000 other things that make it secure, or just because it's the newest thing and we haven't applied the quantum computer to break the encryption. It's interesting. I like the concept, but we are years away from the quantum internet. So is there a hybrid solution or something that we can start leveraging along the way to make us more secure between now and then?
I think so. Yeah, there's a few things. So QKD, which is quantum key distribution, it uses quantum entanglement to securely generate and distribute encryption keys between nodes. So while the actual data transmission and processing would occur classically over existing networks, we could have a level of quote unquote unhackable security, not possible otherwise. You could do some quantum optimization. So leveraging quantum processors to accelerate optimization tasks like finding lowest energy configurations, optimal routes, even machine learning clusters, once we get to a point where it's a viable use. And then there's things like quantum simulation, quantum machine learning. And there's a new concept. It's called quantum resilient encryption, or quantum secure quantum resilient encryption, which is the way that the algorithm is built. It should be theoretically, because no one's really tested these from a quantum computer, but should be resilient to quantum decryption. So there are quite a few companies who are developing some QREs out there, which is really interesting. But there's tons of other hybrid kind of solutions that are out there that could potentially quantum assisted sensing, which is incorporating quantum sensors like atomic clocks or magnetometers or quantum illuminators into hybrid devices for enhanced precision beyond classical limits. So a lot of cool, interesting hybrid concepts, viable hybrid concepts.
So if you're watching online, you can leave a comment on any platform, Twitter, YouTube, LinkedIn, and we can see it and respond to it. Thanks for watching. So how much of an issue is this? Like, from what I hear and understand, most of our issues come from social engineering when it comes to credit card theft and, the how much actual of this fraud or stuff, or is the transaction online being hacked versus any other number of things? Right
now, not much. It's more of social engineering or exploiting zero-day vulnerabilities. That's how most of these hackers are getting your information and hacking things. But the theory of quantum computing is that it's going to be able to crack any current encryption within seconds, just because of the way that it's able to handle data and able to the algorithm is able to work through the encryption algorithm. So it's right now, currently, again, it's just a lot of social engineering. It's installing malware, getting people to open up attachments or open up emails, and then getting access to someone's computer who has access to the database of that company. Speaking of which, I think Atlassian just had a huge hack, one of the biggest hacks in history. But I don't know what the source of that hack was. But again, it's again, back to you. It's social engineering and exploiting zero-day flaws, essentially, in order to get access to a lot of this data. It's scary, though.
Yeah, I agree. That's scary. That's why I look at this and say, okay, this is great. Can we apply this instead or in addition to, our VPN? I go to a coffee shop almost every day, and I'm logged in public Wi-Fi. VPNs are only so much secure because you got your endpoints that are hackable, and there's a bunch of other things that people talk about, vulnerabilities and whatnot. But can something like this make it more secure, where it's not just a transaction that's secure, but all your traffic?
Yeah, absolutely. I definitely think so. Based on my understanding of quantum mechanics and quantum physics and things like that, I think so. So again, right now, yes, but 20, 30 years down the road, once this is actually implemented, who knows what people are going to come up with in order to break this or hack it, right? Just like back in the day when we had, what was it? Who was that encryption algorithm that was unhackable? And then I think it was like 10 years ago, it was hacked. So there's everything. I think everything is hackable. We'll have to see when it comes to quantum, though.
Are you thinking PGP?
PGP. No, PGP hasn't been hacked, has it?
No, I know. I don't know the algorithm that was hacked.
Is it something RSA?
Oh, okay. The RSA token algorithm. Yeah. Okay. They've got a few.
Yeah. But there is a cool concept out there that they're using for actually completely random number generation. I think it's from Cloudflare. And I don't know if you've heard this. I know we're digressing a little bit, but they've got a wall of lava lamps. And those lava lamps have cameras pointed at them. And those cameras are used to generate completely random numbers. And those are definitely, absolutely 100% random numbers, because it's not a computer generating it. It's based off of taking an instance of a lava lamp. So using that, I think, is a huge advantage in overcoming some hacking. But again, the next logical step here is quantum.
Yeah, I agree that you say the next logical step is quantum. I'm still a quantum computer skeptic. I want to see some proof that it works consistently. versus some of the stuff we've been talking about. We had a whole episode on quantum stuff a while back. So I was looking at, was RSA that was hacked by, and their algorithms were stolen and whatnot.
Yeah.
When are we going to see something like this? Like, we always want to see the next stage in performance of encryption and protection, but we always talk about stuff, way in the future. And quantum, as far as I'm concerned, is way in the future. Some people tell us it's going to be right around the corner. But you're talking about quantum laptops are 20, 30 years away when we were talking about it, but different quantum technologies are closer. Are we going to see a hybrid closer? We talked about the hybrid, but what is going to be the first implementation of these things? And are we going to see them on Shopify accounts, or is it only going to be major?
Who knows? Yeah, maybe Shopify is working on something. Great Canadian company that we have there, but I think we're far off. We do have these proofs of concepts, and proofs of concepts are great, showing that there is viability there. But when it comes to quantum, any kind of quantum entanglement, the qubits are very, very noisy right now. And we need to be able to quiet those qubits, noisy qubits. And so we're very limited in what quantum technology can do right now. In order for us to get somewhere viable, I think quantum encryption is closer than a full quantum internet, if that makes sense. But I'm thinking, if we're talking quantum laptops are 20 years away, I would say quantum internet is not too far behind that, maybe 15 to 25 years, right in the middle.
Wouldn't you assume that the quantum internet would be before laptops?
You would think so. Yeah, you'd have the big ass
server rooms and infrastructure.
Yeah, server rooms, and then you'd have your old 486 desktop type quantum computers, and then maybe we get to laptops. So maybe we just jump right to laptops. Who knows?
Yeah, I'm the quantum skeptic. I think there's going to be something else, and quantum's going to be a long way out, and we're going to come up with something else to jump to the next computing level. But we'll see.
What did I just read? I think there was an article I just read about graphene being used in chips, but who knows I think that's just for miniaturizing it more, not for the power that we need that relates to quantum, but.
Absolutely. So we'll have to see what happens. I'm excited about this because I like the interesting technology. I'm not really sure about, how important it is to have unhackable shopping transactions, or what a leap forward this is versus how much of the actual in-process transactions are hackable now.
Yeah.
And get hacked, because like we say, most of the stuff we see is malware that's taken over, or it's social engineered stuff, like shutting down the big companies. Now it's this the ransomware stuff that everybody seems to be being hit with, and no one seems to be doing anything about to stop.
Yeah, no, it's crazy. But again, there's so many limitations and challenges, and I see your skepticism, and I can see why you would be skeptic. But me, I'm the optimist here. I'm the optimist prime here, and I do see it. But again, I haven't done a deep dive into actual where we're actually at with a lot of this stuff, other than articles and doing some deep some follow up on that. But I'd be interested to see. Yeah, I did see one quantum computer, IBM's at CES, which was really cool to see. But apparently, the size of it is mostly just because it needs a lot of cooling.
Makes sense.
Yeah, just like the first computer, right?
Yeah, so it'll be interesting to see where this technology goes, and we'll keep an eye on it and keep you informed here.
Wow, that was amazing.